Hey everyone, let me introduce myself first. So this is Prasad Kumbar. I'm BM Tech graduate. So basically, I'm having 5 years of industry experience. So after that, I'm having probably 6 years of teaching experience, especially in physics. So from 6 years, I'm handling the physics both NEET and JEE level. Right. So now hope you have cleared the first year exams now, right? So now we are going to start the second year lessons, right? So in the first year we have seen the two parts, right? In the physics we have seen two parts. So basically the first part includes what do you mean by units and measurements, motion in a straight line, what do you mean by motion in a plane, right? So then we have seen what do you mean by laws of motions, work energy power, gravitations, and system of particle and rotational motion. Now, in the second part, we have seen what do you mean by KTZ, what do you mean by thermodynamics, what is the thermal properties of a matter, then what is the mechanical properties of solids and fluids, then the last part, what do you mean by oscillations and waves, right? So now, in the second year, before entering into second year, we need to understand some basic concepts. We need to thoroughly understand what do you mean by basic graphs, right? We have seen the what do you mean by basic graphs, right? So what is a straight line graph, what is a rectangular hyperbola, what is a parabola, what is the ellipse part, what is the circle part. So right, so basically we have to understand all these basic graphs, right? Now, before understanding the second year concepts, right, like electrostatics, we will see that. Before understanding the second year concepts in the chapters, we need to understand the most important concepts, that is vectors, right? See, basically in the motion in the plane, we have seen the first part as a vectors. In the vectors, we have seen the different type of vectors. What do you mean by different type of vectors? See, we have seen what do you mean by equal vectors, like a parallel vectors, anti-parallel vectors. What do you mean by negative vector? What do you mean by coplanar, collinear, co-initial, co-terminal, right? What do you mean by zero vector? The most important vector, that is a unit vector. What is a unit vector we have seen, right? What is the use of a unit vector? How exactly we are dealing with the unit vector? All those things we have seen. But whenever we are starting the addition of vectors, see it, in the simple algebraic, suppose there are two scalar physical quantities. Let's say there are two masses, 5 kg and 4 kg. If we are adding those two scalar physical quantities, we will deal with the simple algebraic addition. Suppose say, let's say 2 kg and 4 kg, right? It is in the kg. It is a scalar physical quantity. We will simply say the sum of these two quantities as a 6 kg, right? Whenever we are dealing with the vectors, suppose say, let's say displacement is a vector physical quantity, force is a vector physical quantity. Let's say we are moving 2 meter in the east direction. Let's say a person is moving 2 meter in the east direction, then he moves in the north direction of 3 meter. It is in the north direction. If I ask what is the addition of these two displacements, then we cannot say as a 5 meter east north, no, right? We cannot say like that. So to understand these two physical quantities, to understand the sum of two vector physical quantities, we are going with the two additions, right? Two types of additions. The first one is triangular law of vector addition. Then the second one is parallelogram law of vector addition. Simply we will say this is the resultant we are getting after adding these two vectors. We have seen, no, what is the resultant? R equal to under root a square plus b square plus 2ab cos theta. That is the magnitude. Whenever we are going with the direction, we are taking the tan theta, right? B sin theta divided by a plus b cos theta. So all those things we have seen in terms of addition of vectors, right? If two vectors we are adding, we are going with the two laws, that is triangular law of vector addition and parallelogram law of vector addition. We will see that how exactly we are getting triangular law, how exactly we are getting parallelogram law, right? After that, we have seen what do you mean by resolution of vector, the most important topic, right? What do you mean by resolution of a vector? Suppose, let's say, there is a block, right? This is a block. Now, whenever we are applying a straight line force, this is a force, then the block will move from A to B point, right? Suppose, let's say, the same block we are taking, I'm applying the force in this direction, making angle theta. Now this block is not moving in this direction, it is moving in the straight line direction from A to B point. See here, the force is a vector physical quantity. Now, if I am applying the force making angle theta in this direction, this block is not moving in this direction, it is moving in the straight line direction. It means that, suppose say, if it is moving in this direction, there is also one force acting in this direction which is responsible for moving in the straight line direction. Now this force we are resolving into two components because it is a vector physical quantity. Now this is one component, this is one component, the horizontal component and the vertical component. In the horizontal component, we are taking it as a f cos theta, here we are taking it as a f sin theta. So basically here f cos theta is responsible for displaying this block from A to B point, right? All those things we have seen. We will see that. We will see that again. Then only we will move with the concept of electrostatics, right? Then we have seen what I mean by multiplication of vectors. If we are multiplying two vectors, how exactly we are multiplying? See here, if we are multiplying two scalar physical quantities, exactly 5 kg plus 5 kg into 3 kg, we are taking it as a 15 kg. But if we are multiplying two vectors, we cannot go with the simple multiplication. We have some rules, right? Vector multiplied by vector, which is giving a scalar, we are calling it as a dot product. Vector multiplied by vector, which is giving another vector physical quantity, we are taking it as a vector product, or we are taking it as a cross product, right? We will see all those things, right? So now, basically here in the second year, to understand the second year concepts, we need to understand all these basic concepts, right? In the second year also, we are having two parts. The first part, we will see, in the first part, we will see electrostatics, right? The first lesson is electric charges and fields. In the electric charges and fields, we will see what I mean by charge, how exactly it is existing, right? What is the properties of a charge, what is the methods of charging, right? After that, we are seeing what I mean by electric field, different cases of electric field, dipole, all these things we will see in the electric charges and fields, right? The second chapter, we will see electrostatic potential and capacitance. Then we will see current electricity, then we will see moving charges and magnetism, then magnetism and matter, then electromagnetic induction, electromagnetic waves, then the alternating current. This is the first part. See, in the second year, everything is connected. The first part is connected from first chapter to the alternating current chapter, right? So easy, it's compared to easy than first year, right? Then in the second part, we will see ray optics and wave optics. First we will see optics part, ray optics and wave optics. Then we will see modern physics. Basically the modern physics we are studying from 1900 physics, right? In the modern physics, we are seeing the first lesson, that is the dual nature of radiation and matter. Radiation means light, right? Light is behaving as a two nature, particle nature as well as a wave nature. How exactly it is behaving, that we will see. Then the matter or particle or matter, we are taking it as a particle nature or as well as wave nature, right? That is also we'll see the dual nature of radiation and matter. Then we are seeing what do you mean by atoms, what do you mean by nuclei. See, in the atoms, basically you people have studied in the chemistry part, right? So what is basic nucleus part, right? What is nucleus, what nucleus contains, how exactly electron is revolving around the nucleus, right? What is excitation energy, ionization energy, all the things, lambda, how exactly it is propagating, all the exciting, right? All the exciting, how exactly wavelength is changing, all those things we have seen already. But still in the physics, in the modern physics part, we will see in the deep what do you mean by atoms, what do you mean by nuclei, right? Then the last chapter, that is semiconductor electronics. In the semiconductor electronics, the main part, that is logic gates. So we'll see that, right? So this is the second year whole syllabus, right? So now basically I am teaching from the basics, right? So here this channel learn the ropes, right? My channel name is learn the ropes. Basically I am teaching from the basics. First I will teach what is the theory part, right? The derivation part, theory part, everything is included, right? For the second year exams, theory exams. Then in the theory part itself, whenever we are dealing with the theory part, I am including first NEET part as well as JEE mains part, right? First theory I am teaching, then we will see the NEET part, right? We will see the different examples, different questions that will lead into the next NEET questions, right? Then JEE mains part, JEE part, JEE synopsis or JEE theory part, then JEE questions, right? So everything we will see from one to one, right? So now I will recommend you people to take the textbook, right? If we are studying for the NEET, right? I recommend you people to take PYQs first, previous year question paper book, and errorless book is a best book, right? It's up to you people how you are handling with the NEET book, NEET questions, right? Or else, or any uh, other books, suppose say like MTC is there, right? You can take any other Allen books, right? Any other books if it is considering only NEET questions, NEET level questions, right? I recommend you people to take one book, one book from anything like Allen you can take, or any we can say Akash, Allen, or else any MTC books, right? Then errorless book, right? Now coming to the JEE mains or JEE advanced part, right? First we need to solve the questions, main questions. I recommend you people to take HC Verma book, or so many books are there in market, or I will refer BM Sharma, BM Sharma book, or higher level Galaxy is also there, Physics Galaxy, right? So many books are there, right? So I will recommend you people to consider first PYQ questions, then examples, best examples for the JEE mains and the advanced. Then we how to solve HC Verma questions, we how to solve BM Sharma questions. Then only we will understand the concepts in a deeper level, right? So this is the pattern we need to take, we need to understand before going, before studying the part in the second year, right? So now before moving into the second year part, we will see basic, right? What exactly we need to understand before going to the electrostatic parts, right? Now we will start with the basic graphs. We need to understand basic graphs first. Why? Because in the electrostatics or electrostatic potential and capacitance, if you see the current electricity in any chapter, we will see the graph. And in the NEET every year or in every 2 years, they are asking the graph part, right? So now in the basic graphs, right? The first one is y equal to mx plus c. If the equation contains y equal to mx plus c equation, simply we will say it is a straight line graph. It is a straight line graph where m is a slope and c is an intercept part. This is the intercept part. If the question or equation y equal to mx plus c, then basically simply we are taking it as a straight line graph. The second one, x square divided by a square plus y square divided by b square equals to 1. This equation represents ellipse graph, right? So x square by a square plus y square by b square equals to 1. If the equation contains this type of equation, then simply we are taking it as a ellipse graph, right? The third one, x square plus y square equal to a square, right? So this equation contains circle graph. This will be our circle graph, right? Now the fourth one, if y equal to x square or x equal to y square, this will be our parabola graph. Parabola graph. The fifth one, where xy equal to c will be constant. This is a constant value. This represents a rectangular hyperbola. This is our rectangular hyperbola, right? We'll see one by one how exactly we are taking the graphs, right? The first one, y equals to mx plus c. Suppose, let's say, if we are taking the first one, y equal to mx plus c. Now, c is the intercept, m is the slope. If I take the graph, x and y axis graph, this is the y, this is the x graph, right? Simply it is a straight line. It is a straight line. What do you mean by that? Suppose the equation contains v equal to u plus at. This is the example, right? V equal to u plus at, right? Now see here, we are taking it as a y, right? Now at will be mx. This is a slope. This will be variable. T is a variable. T is a x, where u is a c. This is the intercept, right? Suppose if I take the graph y equal to mx plus c in terms of v equal to u plus at, then u is the intercept. Now suppose this is a u, this is the v, this is the t, then simply we are taking it as a straight line graph, right? So this is how we are exactly drawing the graph in the straight line or else in any type of these graphs, right? Next, let's say second one is ellipse graph. Suppose x square divided by a square plus y square divided by b square equals to 1, right? X square divided by a square plus y square divided by b square equals to 1. Now in the x-axis and the y-axis, suppose say this is the x-axis, this is the y-axis, this is negative x-axis, this is negative y-axis. See here. Now in this equation, if I say a greater than b, मतलब a greater than b का मतलब है in the x-axis a is greater, in the y-axis b is lesser than the a. Now simply we will take it as a like this. See, in the x it is greater, no? It's exactly look like this. Suppose say, let's say x square divided by 4 plus y square divided by 1 equal to 1. What is a? A is 2, no? A square is 4, but a is 2. What is b? B equals to 1. So a greater than b. What is a? Here it is 2. We can consider it as a 2. Now here it is a 1. Right? So this is the ellipse part. Understood? Suppose let's say in the same example, if I take b greater than a. This is the first one. A greater than b. A. Suppose let's say this is a part. This is b part. B greater than a. Now suppose the equation becomes x square by 4 plus y square by 9 equals to 1. Let's say this is the equation. See here, b equal to 3, no? A equal to 2. So b equal to 3, a equal to 2, b greater than a. Now if I draw the graph, the ellipse graph. Now let's say a equal to 2 here, b equal to 3 here, right? So now simply we will take it as like this. Now this is x-axis, this is negative x, negative y, this is positive y. This is how exactly we are drawing the graph, right? So in the ellipse part, right? So circle x square plus y square equal to a square. A is a radius value. Simply we will take it as x. In the circle, we will take it as a as a radius. We know that in the mathematics part, right? Now we will go with the fourth one. Fourth one is y equal to x square or x equal to y square. See, if y is depending upon x square or x depending upon y square, the maximum power is 2, the other one is 1. Then only we can consider it as a parabola. How exactly we are drawing the parabola? See here. Suppose y equal to x square. Let's say we are taking y equal to x square. If I take the graph of y equal to x square, right? This is x axis, this is y axis, right? Suppose if x equal to 1 or x equal to 0, y is also 0, no? Right? Suppose say x equal to plus 1, then y becomes plus 1. Right? Let's say suppose say x equal to minus 1. If I am taking x equal to minus 1, then y becomes minus 1 whole square. It will be plus 1. Correct now? Suppose x equal to plus 2. What is y? Y is becoming 4. Right? Suppose x equal to minus 2. What is y? See, x equal to minus 2 matlab minus 2 whole square. Minus minus becomes plus. So y equal to again plus 4. See here, we are considering x as plus or minus. But y we are getting the y value is always a positive value. इसका मतलब क्या है? Minus x minus y is always a positive value, but x may be positive or negative. So we are considering this graph like this. Understood, right? So this is the equation of y equal to x square, where the graph becomes like this. Understood? Suppose we are taking this equation now, x equal to y square. X equal to y square. See, again, suppose x equal to 0, y equal to 0. Correct no? X equal to plus 1. X equal, sorry, y equal to 0. Sorry. Y equals to 0. X becomes 0. Y equal to plus 1. Correct? X is becoming 1. Correct now? So now y equal to minus 1. What about x now? X again is a positive value. Minus 1 whole square will be positive value. Right? X equal to 1. Y equal to plus 2. X equal to plus 4. Y equal to minus 2. X again plus 4. See here. Y may be positive or negative in this equation. But x we are getting is always a positive. X we are getting always a positive value. So now if we consider the graph like this, right? This is plus x, this is minus x, this is plus y, this is minus y. X is always positive, no? Right? Iska matlab here we need to understand y may be positive or negative, so it becomes like this. Correct, no? Right? X equal to y square. X is always a positive value, right? Y may be positive or negative value. Y minus 1, x equal to 1. So y minus 1, so x may be 1. X is always a positive value. This is how exactly we are drawing the graph with respect to straight line, ellipse, circle and parabola. In the parabola, we will take another examples. With respect to negative values, how exactly we are dealing with the negative values, we will see that also. Right? See here. Suppose let's say in the parabola, we are taking y equal to minus x square. Right? So we have taken y equal to plus x square. Now we are taking y equal to minus x square. See here. When x equal to 0, y becomes 0. Correct, no? When x equal to plus 1, x equal to plus 1, y becoming minus 1, no? See, x equal to plus 1, 1 square 1, y equals to minus 1. Now, x equal to minus 1, what is y now? What is y? See here, x equal to minus 1, see, minus 1 whole square plus 1, plus into minus, minus, so y equal to minus 1. Understood? Now, x equal to plus 2, y becomes plus 2 whole square 4, minus 4. Now, x equal to minus 2, what is y? Minus 2 whole square plus 4, again plus into minus, minus, so it is becoming minus 4. See here, x may be positive, negative, but y becoming always a negative value. Correct, no? So now if we consider the graph like this, right? This is plus x, this is minus x, this is plus y, this is minus y. See here, y is always negative, no? Iska matlab it has to come here. It has to come here. X may be plus or negative. X may be plus or negative. So the graph becomes like this. Correct? Understood? So now the same from the equations, whatever we are learning in the electrostatics or current electricity in anywhere, if we are learning the equations, we have to see how exactly it is depending. It is depending upon minus x square or x square. See, in the trajectory of projectile is a parabola, no? We have take the equation like y equal to x tan theta minus gx square divided by 2u square cos square theta. See, y directly proportional to minus x square, no? Right? Everything is constant here. Y, it is like y equal to minus x square. Y equal to minus x square. So it is coming as a parabola. Understood? So now like this we will understand how exactly we are drawing the graph. Right? Now the fourth one, x equal to minus y square. You tell me how exactly we are getting. See here, y equal to minus x square means x may be positive, negative, but y we are getting always negative. Here x we have to get always a negative value. See here, how exactly we are getting. Suppose say y equal to 0, x equal to 0, y equal to plus 1, x equal to minus 1, y equal to minus 1, x equal to again minus 1, minus 1 whole square plus 1, plus into minus, minus, we are getting minus 1, right? Y equal to plus 2, we are getting x equal to minus 4, y equal to minus 2, x we are getting as a minus 4. If we take the graph in terms of this is plus x, this is minus x, this is plus y, this is minus y. X is always negative value. Iska matlab we have to come here, right? So now this graph becomes like this. Understood? Right? Like this we need to understand the graph, right? The last one, rectangular hyperbola, right? Xy equal to constant c, where c is a constant value. Right? So now if we take the graph x and y axis, this is x, this is y, right? Now rectangular hyperbola will be like this, right? Xy equal to constant value. See here, suppose say, let's say now if xy equal to c, constant value, now y equal to c by x, correct, no? If x equal to 0, y becomes infinity, correct, no? If y equals to 0, x becomes infinity, correct, no? See here, if y is greater, x becomes less, or else x becomes greater, y becomes less. This is the rectangular hyperbola. So what is the example? Suppose let's say we are taking about, suppose say PV equal to nRT, right? Where RT is a constant, n is a constant value, correct? If we take the graph of PV, then it will be rectangular hyperbola, correct? So like this we need to understand what are the basic graphs, how exactly we are drawing the graphs in terms of straight line, in terms of ellipse, in terms of a circle, in terms of a parabola. Parabola is very important. Then in terms of rectangular hyperbola. Clear? So now these are the graphs we need to understand before moving into the second year part, that is the electrostatics part, right? Now, see, in the first year, again it will connect in the second year. In the first year, we need to understand what are the units, right? What is the SI unit? What is the CGS unit, right? How exactly we are converting, right? SI to CGS, CGS to SI, right? All those things we have seen. The dimensions formulas are very important. Dimension formula, what is, they will ask what is the dimension formula of like F, what is the dimension formula of work, what is the dimension formula of pressure, right? In the complex equations, they will ask what is the dimension formula of a required data, right? Required required the value, right? So all the dimension formula we need to understand before moving into the second year part. Now, the main part we need to understand, that is the vector part, right? So now we have to understand thoroughly what are the vectors, right? So basically we know that if we are adding two scalar physical quantities, suppose say like this is a 2 kg, this is a 3 kg, we are adding these two pens, then we will simply say that the mass of total mass of these two pens is 5 kg, right? Let's say if we are adding two vector physical quantities, suppose say let's say I am applying a force on this F1, right? Again F2 in this direction, right? In any other directions. Now if I take the resultant, if I take the addition of two vectors, then we have to understand the laws, the two laws, right? The first one is triangular law of vector addition, the second one is parallelogram law of vector addition. However, the results we are getting the same to understand the magnitude as well as a direction, right? So now suppose say, let's say the best example, we will take the example, suppose say addition of vectors. Now in the addition of vectors, right? In the addition of vectors, suppose say, let's say the example we will take, the practical example. Now the person is moving 3 meter in the east. Now he moves 4 meter in the north direction. In the north direction. If I am adding these two vector physical quantities, this is a displacement, it is also displacement. We cannot say that 3 plus 4, 7 meter east north, right? Now, to understand this, we will take the resultant part in the opposite order, right? This type of vector addition, we are calling it as a triangular vector addition, triangular law of vector addition. See here, the tail, this is the head, right? Sorry, this is the head, this is the tail, right? This we are calling it as a head to tail method. Head of a first vector is coinciding with the second vector tail. This we are calling it as a head to tail method, right? Now suppose say if I take the resultant part here, simply we will take it as a r equal to under root 3 square plus 4 square, that is 5 meter. Understood? What is the direction? This is our direction, theta. Tan theta equal to b sin theta divided by a plus b cos theta. That from that equation we will understand what is the direction of value, right? Suppose say, let's say, however we know this by the Pythagoras theorem, no, right? Suppose say, if they give 3 meter in the east, right? Now he is heading in this direction, making angle 60 degree. Making angle 60 degree. Now it is in the 4 meter. Now this we are taking it as a resultant part. Now to understand the resultant, we have the equation, that is r equal to under root a square plus b square plus 2ab cos theta. Correct? No? A square plus 2 a square plus b square plus 2ab cos theta. Now what is a? A will be 3 square 9. What is b? 4 16 plus 2 3 into 4 cos 60. Right? So if we solve this, we will get the magnitude. What is the resultant? To understand in which direction he is moving, what is the angle? This is the angle. This represents the direction. So what is the value? Tangent theta equal to b sin theta divided by a plus b cos theta. What is b? See here. tan theta equal to b sin theta divided by a plus b cos theta to understand the direction. Correct? What is b? 4 sin theta sin 60. What is a? 3 plus 4 cos theta cos 60. By this we will get what is the angle tangent theta. So if it is like 45 degree, 30 degree, 60 degree, we'll understand what is the theta now. Right? So now to understand what is the addition of two vectors, we'll go with the triangular law of vector addition. The second part will go with the parallelogram law of vector addition. What do you mean by parallelogram law of vector addition? See here, in the triangular law of vector addition, if if two vectors we are representing both in the magnitude and direction, then the resultant we are taking in the opposite order, which is giving in the both magnitude and direction. This we are calling it as a triangular law of vector addition. We can also call it as a head to tail method, right? The second one is parallelogram. What do I mean by parallelogram law of vector addition? Suppose, let's say there is a block. Let's say there is a block, right? This is a block. Now, from this block, at this point, I am applying a force of F1 vector, and also here we are applying a force of F2 vector. Now, this block neither moves in this direction nor moves in this direction. It moves in the straight line direction. इसका मतलब these two forces are having the net force in this direction. This we are calling it as a F net. Simply we are calling it as a resultant, and it is making angle theta. Correct? See here, two vectors we are keeping in both magnitude and direction. The resultant we are taking in the diagonal part. Here in the opposite part, here we are taking the diagonal part. To understand the resultant, what is the F net? Again we have the same equation, a square plus b square plus 2ab cos theta. Suppose F1 is 3 Newton, F2 is 4 Newton, and theta may be 60 degree. Then simply we will take what is the F net? 3 square plus 4 square plus 2 into 3 into 4 into cos 60. By this we will understand what is the resultant part. To understand the direction, again tan theta equals to b sin theta divided by a plus b cos theta. This is how exactly we are calculating how to take the resultant, or how we are adding two vectors, or in the direction, how exactly we are taking the direction. Understood? So this is how exactly we are dealing with the addition of vectors, triangular law of vector addition and parallelogram law of vector addition. Now, in the vector part, the main important concept, that is resolution of vector. How exactly we are taking resolution of vectors? Resolution of vectors, right? Resolution of vectors. See here, again, we have already seen how exactly we are taking the components, right? Suppose, let's say, one example we will see. Suppose, let's say there is a block. This is a block, right? Now, suppose say block is at A point. I am applying a force in this direction, making angle theta. Let's say this is theta. Let's say we are taking 10 Newton force, right? Theta will be 60 degree. At 60 degree we are applying the force. This block is not moving in this direction. Rather than that, it is moving in this direction. At B point it is moving. It is M. Correct? See here. Now, to move this block from A to B point, 10 Newton is not responsible. Correct? If it is moving in this direction, 10 Newton is responsible. Now, this 10 Newton is not responsible. It has a component value. इसका मतलब in the x-axis, in the y-axis. In the x-axis, we are taking f cos theta. In the y-axis, we are taking f sin theta. See here. However, the block is not moving in this direction now. So f sin theta is not responsible. Only responsible to move this block from A to B point, f cos theta is responsible. So how much force is acting? F cos theta. So what is F? F is 10 Newton. What is angle? Cos 60. Correct? 5 Newton is responsible to move the block from A to B point. This is how exactly we are resolving the components. Understood? This is a basic example. Correct? No? See here, in the projectile also we have seen. See here, in the projectile, suppose say, let's say, if we are throwing a ball like this, this is with the initial velocity, we are throwing the ball, making angle theta. See here, this is x component, ux equal to u cos theta, and uy will be u sin theta. Correct? No? See, u cos theta is helping the object to move forward, where u sin theta is helping the object to achieve the height. Understood? This is how exactly these two components are helping in the vectors. Understood? Suppose we will take another example. The best examples we will see in the resolution of vectors. Suppose this is the first example, this is the second example. Suppose if we are taking the third example in the inclined plane. Let's say there is an inclined plane. Let's say it is an inclined plane. Now on the inclined plane we are keeping the block. This is the angle theta. Now the block has been placed on the inclined plane. See here. Now suppose let's say this block is at rest condition. It is the rest condition. What all the forces acting on this block? See here. The normal reaction is acting here now. Why normal reaction direction is here? Because the normal reaction is always perpendicular to the surface. Correct? No? This is the perpendicular to the surface, not in this direction. Right? So this is how exactly normal reaction is acting. Now, if we take mg, weight, how exactly weight is acting on this block? Weight is acting toward the center of the earth, that is mg. Correct? No? This is mg is acting. See here, mg has two components. This is acting as a resultant. mg has a two components. The first component is this and the second component is this. Understood? See, this is theta, this is 90, this is 90 minus theta and this is theta. Correct? No? इसका मतलब this mg has a two components, one which in this direction, another is in this direction. If this is theta, so this becomes mg cos theta. Right? This becomes mg sin theta. See here, mg cos theta is balancing the normal reaction, where mg sin theta is pushing or pulling this block towards this. Correct? No? If I apply the external force here, right? If mg sin theta equals to F external, then the block is at rest condition. If mg sin theta is greater than external force, then block will come down. Correct? No? This is how exactly we are resolving the components. Correct? Normal reaction always acts perpendicular to the surface. This is the surface, no? So perpendicular to the surface, right? mg always acts toward the center of the earth. Understood? So now let's take another example, best example, simple pendulum example. Suppose let's say right, suppose it is making 2 theta angle, the whole angle is 2 theta, hence this becomes theta, this is also becomes theta, right? The thread, this is a thread, right? Now that here this is m and this is m. Understood? Now if this is a thread, the tension force acts in this direction, no? Why in this direction? The tension force is always away from the point of a consideration. If I consider at this point, it looks like it is moving away from my eyes, right? Tension force is always away from the point of consideration. If I look from this point, then tension force in this direction. Basically, it is attractive nature. Correct? This is the tension force. So now, see here. This is acting like a resultant part. Now, this tension force has two components, where this is in this direction. इसका मतलब this is one and this is one component. Understood? Now, where is the angle now? Here or here? See here. This is theta. This is 90. This is 90 minus theta. Correct? No. See, if I take exactly straight line, then we will understand the value. See, theta 90, 90 minus theta, this becomes theta. Correct? No? See here. Or else, see, this is theta, this is 90 minus theta, and this is theta. Simple, right? This becomes t cos theta, this becomes t sin theta. Understood? What is the weight? Weight is acting toward the center of the earth, mg. Correct? No? Again, mg has two components. This is the resultant part, no? Right? One in this direction, another in this direction. Exactly resultant value, right? See here, if I take the value of angle, so now this will be mg cos theta, right? See, this is theta, this is also theta. Again, we are taking this is theta, this is 90 minus theta, this is theta, this is 90 minus theta, this is theta, right? So now mg cos theta and this will be mg sin theta. This is how exactly we are resolving the components. This is very important. See, in the electrostatics, we will see two charges suspended by a thread, right? Plus Q and plus Q, repulsion, or plus Q minus Q. At what angle? At what angle these two charges are in equilibrium condition? We will say, see here, to balance this, T cos theta equal to mg. Correct? Suppose say there is a charge plus Q, there is a plus Q charge, there is a repulsion force is here, no? Repulsion force equal to T sin theta, T cos theta equal to mg. This is how exactly we are doing with respect to electrostatic part, right? So basic things we need to understand before moving electrostatics, right? Hope this is clear, right? The basic things we need to understand clearly or thoroughly, then only we will understand what is the concepts in the electrostatics, right? So these are the vectors part, how exactly we are adding, how exactly we are taking resolution of vectors, and the next one is multiplication of vectors. See here, vector multiplied by vector, a vector multiplied by vector, if it is giving scalar physical quantity, we are calling it as a dot product or scalar product. Dot product or scalar product. If vector multiplied by vector which is giving again a vector physical quantity, see here, one vector multiplied by another vector, there is no direction, only magnitude it is giving, that product we are calling it as a dot product. So here vector multiplied by vector which is giving another vector, iska matlab magnitude as well as direction we are getting, this we are calling it as a cross product, or simply we are calling it as a vector product. What do you mean by this? See here, suppose say, let's say there is a block, example, there is a block, right? Now at A point block is there, now at F, this is F of 10 Newton, 10 Newton, we are applying in this direction making angle 60 degree, making angle 60 degree. See here, if I apply the force in this direction making angle 60 degree, this block is moving in the straight line direction at B point which is having the displacement of 10 meter, having the displacement of 10 meter. Now by the equation the work done equal to Fs cos theta, no? We know this equation by the work energy power chapter, work equal to Fs cos theta. See here, the external force we are applying as a F cos theta, 10 into cos 60, correct? What is F? 10 cos 60 1 by 2. What is displacement? 10 meter. इसका मतलब कितना वर्क हो रहा है? 50 joule work has been done. इसका मतलब to displace a body from A to B point, if I am applying a force of 10 Newton, it has displaced 10 meter in the 60 degree. The work needed to move from A to B, that is 50 joule. What we have learnt here, see here, F is a vector physical quantity, correct? Now multiplied by displacement is a vector physical quantity, vector multiplied by vector which is giving work as a scalar physical quantity, this we are calling it as a dot product, we are calling it as a dot product. simply we will take it as a dot here, right? To take the equation in the magnitude form, simply we are calling it as a Fs cos theta. So this is a multiplication, first multiplication, where vector multiplied by vector, which is giving scalar physical quantity, right? Vector multiplied by vector, which is giving scalar physical quantity. What I mean by vector multiplied by vector, which is giving vector physical quantity? Torque is the best example. Rotational motion. See here. Suppose say, let's say, if we are rotating any body from the screw, right? I am applying a force here. Displacement is in this direction, right? Now, if I apply a force in this direction, F sin theta is responsible to rotate the value, right? So that we are calling it as a vector product or cross product. All those things we have seen in terms of vectors, no? Right? So torque equal to Fs sin theta. So basically, torque equal to F cross S, right? So basically, torque equal to Fs sin theta. Whenever vector multiplied by vector, which is giving another vector physical quantity, we are taking it as a Fs sin theta with the direction n cap, right? So it is giving vector physical quantity, no, both magnitude as well as direction. Understood, right? So this is a multiplication of vectors, right? Now, the last concept, the basic concept in the first year, the most important part we have seen in the work energy power, that is conservative force and non-conservative force. What do you mean by conservative force and non-conservative force? This is very, very important. See here, whenever we are dealing in the electrostatic part or magnetism, right, or in any ray optics, wave optics, right, we have to deal with the forces, right? What do you mean by conservative force and non-conservative force? See here, if I say the first one is conservative force, conservative forces. The second one is non-conservative forces. This is very, very important. Non-conservative forces, right? See here, in the conservative forces, we have four forces, right? The four forces, we are considering it as a conservative forces. What are those forces? See, the first one is gravitational force is a conservative force. Gravitational force is a conservative force. The second one is spring force. Spring force is also a conservative force. Third one, electrostatic force. Electrostatic force. The fourth one is magnetic force. Magnetic force. These four forces, we are considering it as a conservative force. Rest all the forces are non-conservative force. So what is the difference between conservative force, non-conservative force here? In the conservative force, we are writing two important notes. Note first one. Work done by conservative force, work done by CF. CF matlab conservative force does not depend upon the path. Upon the path, it depends only on initial and final position of the body. Initial and final position of the body, right? So this is the first important note why we are considering it as a conservative force, right? The second one is work done by WD matlab work done by conservative force around a round trip, round trip is always a zero value, See here, let's see the first note point. Work done by conservative force does not depend upon the path, it depends on only initial and final position of the body. What do I mean by this? Suppose, let's say this is a pen, we are taking to some maximum height. Okay? See, if I apply external force, then it will move to the maximum height point. Work done by external force is work done equal to F external S cos 0. F भी इधर है, displacement भी इधर है, correct no? Work done by external force equal to Fs cos 0. If I ask what is the work done by gravitational force, इसका मतलब ये देखो, if I take this block, mg is acting downwards, the displacement is in this direction. What is the angle between F and S? 180 degree. इसका मतलब Fs cos 180 minus Fs. Understood? Minus Fs or minus mgh. We are taking it as a minus mgh. See here, or mgh. Negative indicates the direction. If I take this pen to this height, h height, it is mgh. If I take this pen to the same height by this path, again work done is mgh by the gravitational force, by the conservative force. If I take this pen by this path to the same height, again work done is mgh. Understood? इसका मतलब work done by conservative force is depends upon only initial and final position of the body. How we are taking this direction, this path, this path, this path, it doesn't matter. It is depending upon only initial and final position of the body. Understood? The work done is we are getting by gravitational force, by conservative force is mg. See here, you will see that. See here, suppose let's say there is a block. It is a block. Now this block we are taking to this height. This height. Let's say the height is h. I am applying external force in the above direction. Let's say this is the external force. Right? Mg is acting downwards. No, it is a weight force. Mg is acting downwards. Work done by gravitational force. Work done by gravitational force or conservative force in the first path. This is the first path. Now, see, work done equal to Fs cos theta. This is our basic equation, no? Right? What is F? Mg. What is S? H. What is the angle between mg and h? Mg is downwards, h is upwards. इसका मतलब 180 degree. Cos 180 degree minus 1. Work done by gravitational force is minus mgh. In the first part, suppose say the block we are taking like this. We are taking like this. Suppose say the same height we are taking h. This is h1 height and this is h2 height. Correct? This is m1. Sorry, this is m. This is m. See here. This height minus mgh1. Again this height minus mgh2. If I add h1 plus h2, again we are taking h2. Right? Again in the second path, work done by gravitational force we are getting as a minus mgh. Understood? This is the first node point. Correct? This is very, very important. Work done by conservative force does not depend upon the path. It depends only on initial and final position of the body. Now, work done by conservative force around a round trip is always 0. What do you mean by this? See here. Second note. Suppose say there is a block at A point. Now, we are taking this block to the B point. This is B point, making h height, right? External force. Now mg is acting downwards. See, to bring the block from A to B, mg is a force, h is a displacement, angle is cos 180. इसका मतलब work done from A to B equal to minus mgh. Minus mgh. See here. Now this block we are taking from B to A point. B to A point. Work done from B to A point by the gravitational force, not by external force, by the gravitational force, because we are dealing with a conservative force. Gravitational force, no. Now work done from B to A. Now mg is acting downwards, h is also downwards. Understood? No? H is also downwards. Now we are taking the block from upper point to the lower point. H. What is the angle between mgh? 0 degree now. mg is also downwards, h is also downwards. So now work done from b to a will be plus mgh, plus mgh. See, a to b, b to a, round trip. No, this is a round trip. If I add these two work dones from a to b plus work done from b to a, right? A to b, b to a. Now what is a to b? Minus mgh plus mgh, it will be 0. Work done by a conservative force around the round trip is also always 0 1. This is very, very, very important. See, we have seen with respect to gravitational force. Correct, no? So all these examples from gravitational force. If I am applying in the electrostatic force, in the magnetic force, the same values, the same concepts we are applying. See here, the charge we are bringing from one point to another point. Understood? In the conservative force, electrostatic force is a conservative force, no? Right? It is stored as a potential energy. Mgh is a potential energy, no? Work done by gravitational force. Whatever we are doing, the work done by the gravitational force, it is storing as a potential energy. Change in the potential energy, basically change in the potential energy. Plus or minus, we will see that. We'll deal with the plus or minus later. Now we need to understand work done by a conservative force. Whatever we are doing, the work done by the conservative force, it is storing as a potential energy. It is storing as a change in the potential energy. Positive or negative, we'll see later. Understood? So now, in the magnetic force also, the same concept we are applying, right? Now, coming to the non-conservative force. The second one is non-conservative force. Non-conservative force. Don't confuse here. Let's say this is a B example. Let's say this is the A example. A point and B point. Correct now? Now, the best example of a non-conservative force, that is friction force. Friction force. See, it is ulta here. Now, in the friction force, work done by non-conservative force, it is depending upon the path. If you take this pen from here to here or here to here, work done is not same. It is changing because it is a non-conservative force. Understood? Also, work done by non-conservative force around the round trip is not 0. It is adding the value. How exactly it is adding here? Suppose, let's say, the block is present at A point. If I apply an external force in this direction, this will move to the B point. It is at B point. Now, see here, it has gone this much displacement, S displacement. What is the work done by external force? W equal to Fs cos theta, right? Now, friction force is acting in this direction, no? Opposite direction. It is always opposite to the intention of motion, right? It's इसका motion कहाँ है, intention कहाँ है, इधर है. इसका मतलब friction force in this direction, no? Now, work done from A to B. Work done from A to B in the friction force. In the friction force. This is a non-conservative force, not a conservative force. Work done from A to B by the friction force, Fr, yes, Fr in this direction, S is in this direction, cos 180. Correct, no? Work done from A to B equal to minus Frs. This is the work done we are getting where we are taking this block from A to B point. Understood? Now, round trip. Now we are taking this block from B to A point. Work done from B to A point. See here, whenever we are taking the block from B to A point, friction force is acting in this direction. Displacement is in this direction. इसका मतलब friction force, displacement and the angle is cos 180. Correct now? Again cos 180 is minus 1. इसका मतलब work done from B to A point again minus Frs. Understood? If we add these two work done from A to B plus work done from B to A, then we are getting minus 2 Frs. We are not getting 0 here. See, here we are getting 0 value in the conservative force in the round trip. By the non-conservative force around a round trip, we are not getting a zero value. Other than that, it is adding the values. This is the main difference between conservative force and non-conservative force. We need to understand this. Conservative force is very important. See, these 2 points. Whatever we are doing the work done by conservative force, it is not depending upon the path. It is depending upon only initial and final position of the body. Whenever we are doing the work done in the round trip by the conservative force, is always a zero value. It is not adding, it is always a zero value. One more important point we need to understand: whenever the work has been done, whatever we are doing the work done by the conservative force or against the conservative force, it is storing as a change in the potential energy. Understood? See here, in the gravitational force, we are taking one mass. Suppose say this is a mass, there is a mass, right? Attractive nature. One mass we are taking from one point to another point. We are doing the work done, no? Against the gravitational force, we are doing the work done, external work. The work done against the conservative force, right? Against the gravitational force, it is storing as a change in the potential energy. It is storing as a potential energy. We are getting the value as work done equal to potential energy equal to minus G m1 m2 by r. Correct? No? F into S. F is a G m1 m2 by r square into r. R get cancelled. We are getting minus G m1 m2 by r. How exactly we are getting positive value? How exactly we are getting negative value? We'll see that in terms of the electrostatic, right? So all these basic things we need to understand before going to the electrostatic parts. Then only we will understand how exactly we are getting the graphs, how exactly we are doing the work done, how exactly we are getting the conservative force nature, right? All those things we will see in the electrostatics part, right? So basically, in the tomorrow class, we will see what do we mean by charge, right? What is the properties of a charge? What is the method of a charging? How exactly we are charging a body? By which method we are charging a body? We'll see that one by one. So basically, you need to understand thoroughly the basic concepts, right? I will do some numericals. I will go with the best numericals we have, right? Then you have to solve the questions, right? Suppose if I say one part, first, like properties of a charge, what is the methods of charging, I will do some numericals. Based on that, you need to do the numericals, you need to solve the MCQs, then only you will learn the things, right? So now, as of now, we will finish this, right? Write down, note down everything whatever we have seen in the basic concepts. Tomorrow we will see the basic things in the electrostatics, right? Thank you.